Welcome to my viewers once again. We have already discussed the operations on sets and some properties, and we have also discussed the concept of Venn diagram. Here we will discuss a few problems on operations on sets. Now question number 1, say whether the following sets are finite or infinite. Now see, set A, here A equal to x such that x equal to twice of n belongs to set of natural numbers. Now can we find the elements of this set in tabular form or raster form? Let us try to find the elements of this set in tabular form. Now when x equal to 1, here it's x equal to twice n, where n belongs to natural number, n equal to 1, 2, 3, 4, 5, etc. So when 1 equal to 1, the first element will be 2 1s are 2. When n equal to 2, second element will be 2 2s are 4. Third element will be 6, 8, 10, etc. Thus you got the set of even numbers, right? Now it's an infinite set. Since the set of natural number, it's an infinite set, so if you put values of natural numbers here, you will get this set of even numbers. It's an infinite set. A is infinite. Now question number B equal to x such that x equal to 3n plus 1 and n belongs to the set of natural numbers, but n less than equal than 20. Now let us try to write the elements of B in raster form. It says n is a natural number, but n less than equal than 20. That means n will start from 1 up to 20. It says less than or equal than, means those natural numbers which are less than 20, including 20. So when you put n equal to 1, you get first element 3 1 are 3 plus 1 4. When you put n equal to 2, 3 2 is 6 plus 1 7. When you put n equal to say 3 3 is 9 plus 1 10. So you got the interval 4 plus 3 7, 7 plus 3 10, 10 plus 3 13, 13 plus 3 16. And at last when you put n equal to 20, 3 into 20, 60 plus 1, 61. So these are the elements of this set. So it's a finite set, right? From 4 to 61, you will get the elements in between 4 and 61. It's a countable. So it's a finite set. How many elements are there in this set? The cardinal value of this set is 20. There will be 20 elements in this set, right? Starting from 1 to 20, if you put the values of n here, you will get 20 values of this x. So cardinal value of this set is 20. It's a finite set. Now example C, this is B, this is A. C, the set C is given in set builder form. It says that x such that x equal to n minus 1 divided by n, and n belongs to natural numbers. Now let us try to write this set in tabular form or raster form. When you put n equal to 1, if you put n equal to 1, 1 minus 1 divided by 1, 0 by 1, first element is 0. Second, when you put n equal to 2, 2 minus 1, that means 2 minus 1 means 1, 1 by 2. This is second element is 1 by 2. Third element, when you put n equal to 3, 3 minus 1, that means 2 divided by 3. Fourth element, when you put n equal to 4, 4 minus 1, 3 divided by 4. So next element will be 4 by 5, 5 by 6, 6 by 7, etc. Now you see the set of natural numbers contain infinite numbers of elements. So this set will also contains infinite numbers of elements. So C is infinite. Since n is infinite. The set of natural number is an infinite set. So if you put all values of n here, you will get infinite numbers of elements in this set. So it's an infinite set. Now let us discuss question number 2. So question number 2 is the universal set U equal to 1, 2, 3, 4, 5 up to 15. And set P and Q are defined under this universal set. P equal to x such that x equal to n square, n is a natural number. Q equal to x such that x equal to 2 to the power n, n is a whole number. Write P and Q in roster form. Find cardinal numbers of P and Q. Now here universal set, you see, universal set is defined as U equal to 1, 2, 3, 4, 5 up to 15. Now you see P and Q, the elements of P and Q should be within universal set. So let us find those elements of P and Q which we will find under universal set. Let us solve this. P equal to x such that x equal to x belongs to x equal to n square, n belongs to the set of natural numbers. Now let us try to write the elements of P in tabular form, roster form. Now if you put n equal to 1, here it says n belongs to natural numbers. So if you put n equal to 1 here, so what will you get? 1 square, n x equal to 1 square means 1. When you put n equal to 2, 2 square means 4. When you put n equal to 3, x equal to 3, n equal to 3, x equal to 3 square means 9. When you put n equal to 4, you will get 4 square means 16. But 16 is not within the universal set. 16 is not an element of U, so we cannot consider n equal to 4. So when you write P in roster form, you get these 3 elements only, right? Similarly, Q equal to x such that x equal to 2 to the power n, n is a whole number. Now let us try to write Q in roster form. Here it says x equal to 2 to the power n, but n is a whole number. Now whole numbers are starting from 0. So when you put n equal to 0, what will you get? 2 to the power 0. 2 to the power 0 means 1. First element is 1. Second element, if you put n equal to 2, 2 to the power 2, 2 to the power 1. Second element is 2 to the power 1 equal to 2. 2. Third element is 2 to the power 2. That means 4. 4. Fourth element 2 to the power 3. This is 8. 8 is an element of universal set. Fourth element is 2 to the power 4 equal to 16. But 16 not belongs to U. So we cannot consider 2 to the power 4. That means for n equal to 4, you will not find the element within the universal set. So elements of Q will be 1, 2, 4 and 8. So you got 2 sets here, P and Q. You find that common element is 1 and 4. So you will write 1 and 4 here. P is this. So within P you got one more element here, 9. Q is this. Within Q you will find 4 and 8. And there are some elements in this universal set which are not inside P and Q. What are those elements? You see element 3, 5, 6, then 7, then 10, 11, 12, 13, 14, 15. These elements are elements of U but not elements of P and Q. Now let us find NP. What is NP here? 3. And Q, cardinal number of Q is 4. There are 4 elements in Q. This. Now let us try to solve this question number 3. A equal to X such that X is a natural number less than 6. B equal to X such that X is a natural number multiple of 3. Find A union B and A intersection B. So let us try to solve this. Here A, let us try to write the elements of A in a raster form. X is a natural number less than 6. So what are the natural number less than 6? 1, 2, 3, 4, 5. And B equal to X is a natural number multiple of 3. So find the multiples of 3. X is a natural number multiple of 3. 3 1 is 3, 3 2 is 6, 9, 12, 15, etc. Now what is A union B then? A union B. A union B equal to, you will find that A union B means those elements which are in A and B. So we will write 1, 2, 3, 4, 5, 6. And starting from 6, you will get only multiples of 3, 9, 12, 15, etc. Right? If you find union of A union B, then you will have to write the elements of A and B combined together without repeating the same element. 3 is common here, we will not repeat here. So A union B is this set. And what is A intersection B? A intersection B means common elements of A and B. What are the common elements of A and B? Element B, 3 is common, and beyond that there is no element. So it is a singleton set. A intersection B means only 3. Now let us discuss question number 4. If A equal to X such that X is a natural number, B equal to such that X is an even natural number, C equal to such that X is an odd natural number, D equal to X is a prime number, find A intersection B, A intersection C, A intersection D, etc. etc. So let us solve this. Let us try to write the elements of A, B, C and D in tabular form. You find that X is a natural number, so it is the set of natural number, this set. B equal to X is a even natural number, so even natural numbers are 2, 4, 6, 8, 10, etc. C equal to X is an odd natural number. Odd natural number means 1, 3, 5, 7, 9, etc. And what is D? It's a prime number, 2, 3, 5, 7. So let us try to find A intersection B. A intersection B means the common elements of A and B. So what is common here? You will find that all even numbers are common, 2, 4, 6, 8, 10, etc. A intersection B. Actually B is a subset of A here. All even numbers are natural numbers. So A intersection B means here B. A intersection C. What is A intersection C? Common elements of A and C. See, you see this is the set of odd numbers and this is the set of natural numbers. Now all odd numbers are natural numbers. So finally you got 1, 2, 3. That is the set of natural numbers. So A intersection C means A only. A intersection C means C only. Common elements. These elements are inside A. C is a subset of A. So A intersection C means the set of odd numbers 1, 3, 5, 7, 9, etc. It's a set of odd numbers. So A intersection C equal to C. Find A intersection D. What is A intersection D? It is the set of natural numbers. D is the set of prime numbers. Now we see all prime numbers are natural numbers. So A intersection D means you will get common elements of A and D. That means the prime numbers. So A intersection D equal to D. Here. Now let us find B intersection C. What is B intersection C? B is the set of even numbers. C is the set of odd numbers. So there is no common element here. That means B intersection C equal to 5, null set. Similarly, B intersection D, B intersection D. Here you say you got these are even numbers and these are prime numbers. Now there is only one common element here. This is the even prime number. It's a singleton set. C intersection D. What is C intersection D? C means odd natural numbers. It's a prime numbers. Now there are some numbers which will be common to C and D. C and D. What is common here? 3 is common. 3 is common. 5 is common. 7 is common. 9 is not common here. Then you got 11 is common. Then you got 13 is common, etc. So you got this set. These are odd numbers, but they are prime, right? So C intersection D means the set of odd numbers, but they are prime. They are not composite. Let us question number 5 here. Which of the following pairs are disjoint sets? Solution. Here A equal to 1, 2, 3, 4. A equal to 1, 2, 3, 4. This set. B equal to X such that X belongs to N and 4 less than equal than X less than equal than 6. So let us try to write the elements of B in tabular form here. What are the elements of B in tabular form? Those natural numbers lying in between 4 and 6, including 4 and 6. That means 4, 5 and 6. So what is A intersection B? Here A intersection B means common elements of A and B 4. So since A intersection B is not 5, A intersection B not equal to 5, it's not a null set. Therefore A and B are not disjoint. Disjoint means when they have no connection, there is no common element. Now we got one common element in between A and B, so A and B are not disjoint. Now B, question number B, here it says X is an even integer. First set is even integer. So even integer means say for example -4, -2, 0, 2, 4, etc. And X is an next set is X is an odd integer. Odd integer means say for example -3, -1, 1, 3, 5, etc. Now see there is no common element in between these two sets. So if you got intersection of these two sets, answer is 5. Therefore they are disjoint. These two sets are disjoint. If you find the elements of this set in a roster form, these are the elements, and elements of this set in roster form, tabular form, this. Now there is no common element in between them, so they are disjoint sets. Now let us try to solve question number 6. If R equal to set of real numbers, Q is the set of rational numbers, find R minus Q. Now you see, set of real numbers is the union of Q and Q naught, where Q naught equal to set of irrational numbers. Set of real numbers means the set of union of Q and Q naught. Q is the set of rational numbers. Rational and irrational numbers are together called real numbers. So R is the union of Q and Q naught. So when you find R minus Q, then you will get Q naught, right? That means those elements which are in R but not in Q, that means irrational numbers. So R minus Q is irrational numbers. And what is Q complement? Q complement means, what is Q complement? X such that X belongs to R but X not belongs to Q, right? So Q complement means those elements which are in R but not in Q. That means again you got Q naught. So Q complement equal to Q naught. Q naught means that are set of irrational numbers. And what is Q union Q complement? This equal to Q union Q complement means Q naught. So rational and irrational, if you find the union of rational and irrational numbers, you got this set of real numbers, right? So Q union Q naught equal to R, this set of real numbers. Okay, thank you viewers. We will discuss some more examples in the next class.